Good afternoon, Mr. Zarnecki here with a review on inverse relationships. Okay, this standard basically says you need to know how to use inverse relationships for addition and subtraction, multiplication and division, okay? In order to solve, you're going to simplify computations and you're going to solve problems. What does that mean? Very simply, it means this. It says, hey, if I multiply some number, and we're going to call this some number, we're going to use a variable called n, okay? I multiply that number, any number, by a half. It's the same as saying I took that number and I divided it by 2. I multiply by a half, which means I divided by 2. And this is only one part of the whole process. So we'll use this as an example to start. Any number, it doesn't matter what the number is, okay? In this case, if I make n any number over 1, the value is still n. Any number divided by 1 is the number itself. So 8 divided by 1 is 8. 3 divided by 1 is 3. Whatever the number is, over 1 is still this number. So I now have two fractions here. What do we do to solve multiplication? We get our answer when we multiply fractions. Well, when we multiply, we want to multiply straight across. Straight across. Numerator times numerator. Denominator times denominator when we are multiplying. Here, so I have n times 1. Well, n times 1, some number n times 1 is n. Any number times 1 is that number itself. 3 times 1 is 3. 4 times 1 is 4. 8 times 1 is 8. So here we just get the number itself, whatever it is. Here we go 1 times 2 is 2. And now I have exactly the same looking thing. Like, ooh, what's that? Well, if we go back a second, okay? Go back to what we said a minute ago. And what I will do is I will write it on the bottom here so that you can see it again. N times 1/2 is the same as n divided by 2. All this is really is one step before we actually get to this step. Okay? Once we process this out one step, we wind up with the same thing. This will work, okay, for any number. We're going to try another example too. And it doesn't have to be 1/2. Here's what we need. Let's pick a number. Instead of using n, let's pick a number. Let's use 9. Okay, I'm going to use 9 this time as a number. I'm going to multiply 9, okay? Multiply it by some fraction, okay? It doesn't have to be a half. The whole premise, okay, is that we have a fraction. Your numerator will always be 1. Numerator, always 1. Okay? Your denominator can be anything. What does that mean? I could have a 3, I could have a 4, I could have a 5, it doesn't matter. Let's 9, 8, make it 8. What we're saying is the same as down here. This will be the same as my original number, 9, divided by whatever my denominator is. So we're going to say this should be the same as 9/8, okay? And we know that's an improper fraction. But for this purposes, we're going to leave it that way so you can actually see it come together and how it is exactly the same. So here, I have a numerator of 1, any denominator, whatever my fraction might be, and then we just picked any number. In this case, we picked 9. So what I'm going to do, we're going to make this over 1. Because any number over 1, like we said down before, is the number itself. So 9 divided by 1 is still 9, okay? But I'm going to put it as a fraction. Then what do we do when we make an answer here, when we multiply? We're going to multiply straight across. Straight across. So here I have 9, my numerator times numerator. 9 times 1, 9. 1 times 8 is 8. And here again, you can see where the two equal each other. This works for every example as long as my fraction has a 1 in the numerator. Why? Because that 1 will multiply by this number and will always then be over the same denominator. Okay? That's why it works. That's all that this standard is. It's all this standard covers. Okay? And the question may become not if you understand this concept as much as if you can apply it to word problems, okay? You need to stop, you need to think about it. We talked about solving our word problems, all right, and any problems. Substitution, okay? Plug in an easy number for n. If you see n as part of your problem, substitute. Give a nice, if I'm multiplying by 2 and then I know my answer choice is I have to divide by 2, why not use 2? Why not use 4, a multiple of 2? Okay? Plug it into your problem, get an answer, and then plug that same value for n, or whatever variable they're using. Plug it in for that same value, that variable, in A, B, C, D, your multiple choice answer choices. By plugging it in, you can then do the problem, and whichever answer choice gives you the same answer as the problem itself, that's your answer. Okay? Takes a little bit of extra work, but you're guaranteed to get the right answer. Okay? So, all about doing a little extra work so that we can make sure we get the right problem. No silly errors. There you go. There's your review of inverse relationships. I hope that you like it, and take care.